In this lecture, we're going to talk about the impacts on enzymes. So, in the last couple lectures, we talked about what enzymes are and what their jobs are. Enzymes are a very, very special type of protein that exists in living organisms. And these proteins have the job of catalyzing or speeding up chemical reactions. If we didn't have enzymes, we wouldn't be able to process all the things that life needs to process. Imagine I gave you the analogy of making a fire, right? Imagine if imagine we had to live off of making fires to cook, and we didn't have the technology that we have. And imagine that the only means that you had to start a fire was to rub two sticks together. Would it work? Maybe sometimes. Would it take too long? Probably. So when you think of enzymes, think of throwing gasoline on a fire. It makes it catch the fire quickly so you can use the fire when you need it. So we need enzymes. If your enzymes don't work, your chemical processes don't work, and your body won't function. A perfect example is lactose, right? We talked about lactose and lactase. Lactase is the enzyme that breaks down lactose. If you don't have lactase in your body, you can't digest milk. And if you know anybody who's lactose intolerant, they can't digest milk, and their body they throw up, they get sick because their body can't digest it. That's a perfect example of what happens when an enzyme doesn't work. Your body can't process it. So imagine if none of your enzymes worked. Your body wouldn't work. You would die. It's as simple as that. So there are certain factors that affect how well enzymes work. Just like in most situations, there's certain conditions in which processes work the best, right? So let's take a look here at these three examples. And we have three situations that affect how an enzyme works. We have the pH of a system, we have the temperature of a system, and we have something called substrate concentration. So the first thing I want you to do is I want you to look at these three graphs. Look at the pH graph, look at the temperature graph, and look at the substrate graph. And let's just take a second, and what do you notice as a difference between them? So let's take a second and look at them. What do you see different in these three graphs? What's the impact of the different conditions on how well that enzyme works? Let's look at the graphs, right? So if you take a look here, you can see how well the enzyme works is going to be on this axis here. So in each one of these, you're going to see as it goes up and then it goes down, that's how well that enzyme works, the best effectiveness of that enzyme. So one thing hopefully you look at when you see this is they don't all have the same type of curve. They have some differences there. So what I'm going to do now is I'm going to talk about what's different with each of these three different types of curves. Well, hopefully in the time that I was just talking and you looking at this, you noticed that those three curves look very different. In one here, you can see it's an even distribution where it goes up and then it comes back down. And one side looks a lot like the other side. And in this one, you can see that it goes up and then there's a sharp drop where it seems like it's going up, it's working better, it's working better, it's working better, and then boom, it stops working. And then down here, what you can see is it gets better, it gets better, it gets better, and then it hits a certain point where it plateaus, right? It doesn't go up or down, it just stays where it is. So what I want to do today is I want to talk about what's happening in these three situations. So if you take a look down here, let's look at pH first. If you take a look down here, we have our pH scale, right? 4 being acidic, 11 being very basic. 7 is neutral. Now, if you look at how well an enzyme works, what you'll see is the enzyme doesn't work very well if it's acidic. It doesn't work at all if it's too acidic, and it doesn't work at all if it's too basic. It needs to be close to neutral. Now, as you can see here in this example, for this specific enzyme, the best pH for this enzyme to work is around an 8. So that means if you were to go below an 8, that enzyme wouldn't work as well, and if you were to go above an 8, that enzyme wouldn't work as well. Well, think about the human body. What pH do you think most of our enzymes work the best at? Well, if you said around a 7, you would be right, because that is our pH, right? We are about a 7.2. That's our pH. So most of the enzymes in the human body work the best at that level. Now, there are parts of our body where the pH is different, right? For example, our stomach. Think of our stomach. What's our pH like in our stomach? Well, if you've ever heard of stomach acid before, our pH in our stomach is around a 3. It's really low. So the enzymes there are going to work much better at that lower pH. So depending on the enzyme, this graph is going to change. But one thing I want you to notice is that there is a level at which the enzyme works the best. And in this case, for this enzyme, it would be about an 8. And if it gets too high or too low, it's going to not work at all. Okay? Now, if you look at temperature, it's a little bit different. If you heat something up, it tends to increase its movement, right? So imagine if I had a pot of water and I heated it up. you'd start to see it boil. It would move around, right? And the reason why it's moving around is those molecules are moving faster. Well, if you heat up a system, the molecules are going to move faster, and that's going to make the enzymes work better, right? They're going to increase how effective they are as you increase the temperature of the system. So it gets a little warmer, they move a little faster, they do their job better, and that's going to keep going up until it hits a peak where it's at its best possible effectiveness. So at around 50 degrees Celsius here, that's when this is going to be working the greatest. And then all of a sudden it drops off. It just shoots right down. And the reason why that's happening is because at a certain temperature, those enzymes are going to start to break apart. If I heat you up, imagine if I warmed you up, right? You would feel warm, you'd feel warm, and then at a certain point, if it got too hot, you would die. And the reason why you would die is because your enzymes would stop working. That's one of the reasons why you would die. So essentially what happens here is the temperature goes up and up and up, and then eventually it shoots right down, and the reason why the enzymes stop working is because something happens to them called denaturing, which I'm going to talk about on the next slide. And then finally, we have our substrate concentration. That's how much of the stuff that the enzyme works on. So what's going to happen is if you have enzymes working and you add substrate, they're going to work faster, right? So for example, if I am an enzyme and my job is to break apart, let's say, it doesn't matter what, these little blocks. Let's say my job is to break these little blocks in half. And as more blocks come down the line, I'm going to be breaking them in half. And as more blocks come, I'm going to break more in half, right? So as you can see, how fast the reaction is happening is going to go up and up and up. But at a certain point, it just levels off. And the reason why is because if I don't add more enzymes, it's not going to, at a certain point, they can't handle anymore. Here's a better analogy. Imagine somebody at a grocery store checking somebody out. There's a conveyor belt, right? And as that conveyor belt comes down, the person scans the items. And as more items come, they're going to scan more items. And they're going to go faster and faster. But at a certain point, they can only go so fast, right? That person can only move their arm over that thing so many times. So at a certain point, even if there's more and more items on that conveyor belt, they're not going to move any faster. The enzymes work the same way. At a certain point, those enzymes are going to be completely occupied by substrate, and it doesn't matter if there's more substrate. The enzymes just can't keep up. So it's not that the enzymes are going to stop working. They're just not going to be able to keep up with how fast the amount of substrate there is, so it's going to eventually level off. So just to make sure we understand this slide, these are 3 instances in which enzymes are affected with how well they work. For pH, there's a certain pH at which enzymes work the best. In humans, it's usually around 7 because that's our pH. In different parts of the body, though, that changes. But having that said, 8 in this scenario would be the optimum pH. For temperature, enzymes are going to work better and better and better as you increase temperature until they get to a certain point, and then it just drops drastically because they fall apart because they're too hot. And then finally, substrate concentration. If you increase the amount of substrate, the amount of stuff that the enzyme is working on, the whole rate is going to keep going up. It's going to keep going faster and faster until eventually it just plateaus and levels out, because even if you have more substrate, the enzymes just can't keep up. And then finally, just to make sure we understand something, there's a term that I'm going to be using a lot called denaturing. And what denaturing means is very simply the bonds break. So what is an enzyme? It's a protein. And what is a protein? It's made up of amino acids, right? And those amino acids are held together by peptide bonds. At a certain point, those peptide bonds are going to break. And if the peptide bonds break, the enzyme is going to fall apart and it's going to change its shape. So it's not going to be able to fit. Imagine if I took your key and I melted it. Would it fit into the lock anymore? No, it's because the enzyme no longer has its shape and it can't fit on the substrate. So here's what happens. The enzyme becomes denatured when its bonds are broken and its shape is changed. That enzyme will no longer work. So if your temperature goes too high and the bonds fall apart, it won't work. If the pH changes too much and it breaks the bonds apart, it won't work. So what happens is the substrate can no longer fit onto the enzyme and the enzyme doesn't work. So when does this happen? It happens when your temperature is too increased or your pH level is unfavorable. So if I go back a slide here, what's happening in this temperature scenario? The temperature's going up, the enzyme's working better and better, and then all of a sudden it hits a point where the molecules start to spread apart, those peptide bonds break, and this is where the enzyme denatures and it no longer works. And that's what happens with pH, temperature, and substrate concentration. Thank you very much. Right? So what's going to